Imagine like spending weeks building the perfect application, right? And then you find out it won't launch.
Oh, yeah.
Yeah.
Because of a single totally invisible typo in a file you didn't even write yourself.
Exactly. It's just the most frustrating reality of dealing with these strict digital formats. You have the scaffolding, you have all the data, but the final product just refuses to materialize.
Right, it just sits there.
Yeah. So today we're doing a deep dive into a really specific developer dispatch. It was published today, actually, June 18th, 2026. And it's an excerpt titled Notes on Haskell Programming, Part 165, by an author who goes by Ang.
Part 165. I mean, that number alone tells you we're dropping into the deep end of a very serious long-term commitment here.
Oh, absolutely.
This isn't someone just, tinkering around for an afternoon.
Definitely not. So the mission of this deep dive is to explore how Ang is working on this TET Haskell program, and specifically documenting the process of adding initial support to output an EPUB format file.
Which on the surface sounds incredibly straightforward.
Right, you just hit save as EPUB, right. But as we're going to see, it's anything but simple. So, okay, let's unpack this. Before we get to the really weird bugs Ang runs into, we have to look at the actual code and the architecture being used.
Yeah, that's crucial.
Because why isn't Ang just writing an EPB generator completely from scratch?
Well, building the EP generator from the ground up is honestly a massive and often punishing undertaking. We tend to think of an ebook as just a long text document, right?
Yeah, just words on a screen.
Exactly.
Right.
But under the hood, an EPB is essentially a zipped website.
Wait, really? A website?
Yeah, pretty much. It requires a highly specific, standardized package of XHTML files for the chapters, and then CSS style sheets for the formatting.
Wow. Okay.
Plus XML manifests that lists every single asset in the book, and specialized navigation files just for the table of contents.
That is way more complex than I thought.
It really is.
Yeah.
So if you're building a pet program to do something else entirely, pausing to write thousands of lines of code just to properly zip up some HCL, well, it's going to completely derail your actual project.
Which totally explains why Ang relies on something called the Pandoc API.
Yes.
In the notes, Ang explicitly points out that Pandoc already has built-in conversion for different ebook output formats. So the strategy is to just leverage that API to do the heavy lifting, right?
Precisely. It's the smart move.
I usually think of Pandoc as like a kind of universal translator for documents. You hand it a file in one language and it translates it into the local dialect of whatever format you need next.
Translator is close, but it implies a bit too much nuance. It's honestly more like a master manufacturing mold.
A mold? How so?
Well, a translator still deals with subjective interpretation, right? But Pandoc is entirely mechanical. It relies on something called an abstract syntax tree, or AST.
An abstract syntax tree. Okay, break that down for me. How does a tree help us turn a document into an ebook?
Think of it like taking a fully furnished house and stripping it down to its most basic architectural blueprints.
Okay, I'm with you.
When Pandoc ingests a document, it doesn't care about the fonts or the page margins. It just strips all of that away and parses the document into a strict, abstract tree of purely structural nodes.
So it's just the bones.
Right. It says, okay, this piece of text is a level 1 header. This next block is a paragraph. Inside this paragraph, these 3 words are emphasized.
Got it.
It creates completely neutral mathematical representation of the document's structure right in the program's memory.
I see. So it's breaking the content down to its, like, atomic structural element.
Precisely. And once you have that pure abstract syntax tree, Pandoc can take that mold and pour it into almost any format you want.
Oh, that makes sense.
Yeah, it just maps those neutral nodes to the specific syntax of the destination format.
Okay, that makes the code snippet Ang provided make a lot more sense now. We see a function called convert to ebook.
Right, I saw that.
And Ang is feeding a generalized document into this function. The code shows it routing between different formats based on really simple arguments.
Yeah, exactly.
Like it routes to PDF, it routes to a format called TIP, which the text notes as TIPST, and now it's routing to this new generate EPUB function. So looking at this, what does it tell us about the efficiency of Ang's approach?
Well, it's a highly efficient architecture. Because Ang is using the Pandoc API, that single abstract document can branch into multiple completely distinct file formats.
Without having to rewrite the core logic every time.
Exactly, without Ang having to rewrite anything for each format. It's very elegant.
And a major part of making that routing work smoothly involves handling the metadata, right?
Oh, absolutely.
There's another function here called doc2pandoc, and this is where we see exactly how that abstract document gets prepped. It specifically grabs the metadata, the author, the title, and the year before it folds in the actual text blocks.
Because an ebook needs to know what to call itself when it sits on a digital shelf, right?
Yeah, that makes sense.
By cleanly separating the metadata from the content blocks, Ang ensures Pandoc has everything required to build a structurally complete file. The metadata forms the labels on the outside of the box, and the blocks of text are the physical goods packed inside.
The labels on the box, I like that. But okay, knowing the routing is theoretically perfect actually makes the bug Ang hits next even more infuriating.
Oh, yeah. The classic bug.
Right. The code says it should work, the universal API is engaged, but the output tells a completely different story.
It usually does.
When Ang actually attempts to generate the EPB, the container works, but the substance is completely missing. In the code, Ang includes a function called getUpTemplate, which compiles a default template explicitly named epub3.
With EPUB3 being, the current major standard for the EP format across the publishing industry.
Right. So Ang compiles this standard default template, but then disaster strikes. Ang writes that initially they could view the table of contents of the EPB file, but absolutely not the content itself.
The silent failure.
It's the worst, isn't it?
It is the most dangerous kind of bug.
Oh.
Because the program didn't crash, it just quietly failed to do what you actually asked it to do.
It's such a bizarre outcome. It's literally like buying a house, getting the perfect blueprints, walking in the front door and seeing a beautifully framed directory on the wall telling you the master bedroom is upstairs and the kitchen is on the left.
Right.
But when you actually open the doors to those rooms, they're completely empty.
Just a void.
Exactly. There's no floor, no walls, just an endless void. Why would a default epub3 template give us the map but completely hide the territory?
Well, what's fascinating here is the absolute unforgiving strictness of ebook formats and how parsers interact with them.
Unforgiving is a good word for it.
Yeah. Ang mentions using a console application called epubcheck to verify the outputted file.
Let's pause on that for a second. What exactly is epubcheck and why is Ang running the file through it?
So it's the industry standard validator for EPUB files. It's maintained by the World Wide Web Consortium. Think of epubcheck as a highly pedantic customs agent at an international border.
A pedantic customs agent, okay.
Right. It doesn't care how beautiful your luggage is. If your declaration form is missing one single signature, or if you packed an item in the wrong compartment, it denies you entry and leaves your bag on the tarmac.
Wow, so no exceptions.
Zero exceptions. Ebook readers like a Kindle or Apple Books are notoriously fragile environments. They have to render text cleanly while preserving battery life and managing limited memory.
Oh, I never thought about the memory limitations.
Yeah, it's a big factor. So if a file isn't structurally perfect according to the official specification, the e-reader often just refuses to render it to prevent a software crash.
Okay, so getting the table of contents to render, but not the text, means what exactly in this scenario?
It means the e-reader processed the XML manifest successfully. The labels on the box parsed correctly, so the device understood the map.
But not the rooms.
Exactly. The actual XHTML blocks of content, the text itself, contained something that violated the strict specification.
Like what? What could be wrong?
Maybe a tag wasn't closed properly,
Yeah.
or a required attribute was missing in the default template. The e-reader saw that invalid content, panicked, and essentially just gave up, leaving the reader staring at an empty room.
Which puts Ang in a terrible position. You have an EPB, the table of contents is there, mocking you.
Just sitting there.
Right, the text is invisible. And running this broken file through the epubcheck customs agent is probably spitting back a wall of dense red error text.
Oh, it's definitely a wall of red text.
So how does a developer get out of this frustrating loop? Because in the notes, Ang writes, and the phrasing here is very revealing that, quote, somehow the AI automatically managed to get it right after several iterations, end quote. Automatically.
Automatically. It perfectly captures that exact modern feeling of alienated relief.
Alienated relief. I love that.
Yeah, you're happy the fire's out, but you have absolutely no idea how the fire extinguisher actually worked.
Yes. Have you ever used a tool to fix a problem? And you're grateful it works, but you have no idea how it actually did it. It's so relatable. But wait, if the AI is just throwing spaghetti at the wall until the epubcheck customs agent stops complaining, isn't that kind of a dangerous way to code?
It can be, yeah.
Because you end up with a structurally sound file, but a code base you don't actually understand. If it breaks again next week, Ang won't know how to fix it without asking the AI again.
Well, this raises a really important question about the current evolution of programming. Yes, there's a risk of accumulating black box code,
Right.
but if we connect this to the bigger picture, what Ang is describing is a profound shift in how developers allocate their cognitive load when dealing with arbitrary, highly strict systems like epubcheck.
Arbitrary in what sense, though?
In the sense that EPUB3 specifications, while they're standardized, are incredibly dense and often unintuitive.
I see.
In the past, Ang would have had to manually read the epubcheck error logs, cross-reference them with a hundreds of pages long technical manual, guess what was wrong with the Haskell output, tweak the code, recompile, and run the checker all over again.
That sounds exhausting.
It's agonizing, slow work that has absolutely nothing to do with the actual goal of Ang's pet program. It's just specification bureaucracy.
So the AI essentially acts as a high-speed bureaucrat to handle the red tape.
Exactly. The AI acts as a high-speed trial and error assistant.
Mhm.
Ang fed the broken code and the epubcheck error output into the AI.
Okay.
Then the AI looked at the errors, hypothesized a fix to the template, and provided new code. And plugged it in, ran epubcheck again, got completely different errors, and fed those back to the AI.
Ah, so that's what several iterations means.
Right. The AI brute forced its way through the strict rules of the validator until it found the exact syntax the EPB format demanded.
It just kept hammering at the lock until the tumblers clicked. But, I mean, it still feels a bit like cheating, doesn't it? As a developer, aren't you supposed to know every line of your own project?
That's the old paradigm, honestly. The new paradigm is shifting developers from being syntax writers to being system editors and reviewers.
That's a huge shift.
It is. The AI doesn't necessarily understand the EPB specification in an abstract human sense, but it can iterate through potential structural solutions infinitely faster than a human could ever hope to.
Yeah, that makes sense.
It found the missing structural element that was causing the e-reader to hide the content. Ang is basically trading the deep manual knowledge of XML specifications for the speed of maintaining momentum on the primary Haskell project.
I can definitely see the pragmatic value in that. And hey, it worked. The content is finally visible.
Yep, the house has furniture now.
The house has furniture. The epubcheck tool is happy, giving the file a clean bill of health with, quote, no specification errors. So you'd think that's the end of the story. Part 165 is complete. Time to commit the code and move on, right?
You would think so, but no.
No, because the tone of Ang's notes shifts right at the very end.
Well, passing a technical test is rarely the final goal for a passion project.
Exactly, because Ang writes, quote, while the generated EPUB is viewable and no specification errors so far, we'll need to customize it with our custom template. The ultimate goal here is to achieve an intended layout that matches our preferences.
Right.
So the AI built a functioning house, the inspector signed off on the permits, but Ang still needs to step in and pick the wallpaper.
That's a perfect way to put it. We really have to separate the idea of a file being structurally sound from it being aesthetically pleasing.
They are two very different things.
Very different. And this is exactly where the default EPUB3 template, even when it's fixed by the AI, falls severely short.
But how so? If it passes the validator and the text shows up on the screen, why isn't it enough?
Because a default template is designed to be the absolute lowest common denominator.
Oh, I see.
Yeah, its only goal is to pass epubcheck and put raw data on a screen without crashing the device. But human preference dictates things like typography, margin width, line height, chapter heading styles.
All this stuff that makes it look good.
Exactly how block quotes are indented, all of the nuanced visual language that makes reading a pleasant, engaging experience.
So the AI got the technical hurdles out of the way, but it can't tell Ang what actually looks good.
Precisely. The validation process is purely binary. It passes or it doesn't. But design is entirely subjective.
Right.
The AI was able to iterate its way to a technically correct file, solving the specification errors, but the AI cannot know Ang's personal intended layout for this pet program.
Because it's a personal preference.
Yeah, that requires a custom template, which necessitates human intervention. Ang has to take the structurally sound framework the AI helped create and begin carefully crafting the CSS rules to make it look exactly right.
So bringing it all back to the overarching journey in Part 165, we see this fascinating microcosm of modern digital creation.
We really do.
Ang starts with this highly intelligent foundation using the Pandoc API and its abstract syntax tree, so a cell document can seamlessly route to Typst, PDF, and EPB. The metadata is neatly mapped. Everything makes logical sense.
But logic doesn't always prevent friction.
Exactly. The invisible wall hits. The default EPUB3 template creates that empty house, a working table of contents, but no actual content because the strict customs agent of epubcheck rejects something totally unseen in the code.
Yeah, the dreaded silent failure.
To get past those unyielding rules, Ang leans on the automagic of AI. Instead of spending days reading dry manuals, Ang uses the AI as a high-speed trial and error engine over several iterations until the file is structurally perfect.
And then comes the immediate realization that structural perfection is really only step one.
Right.
The real meaningful work of creating a custom template for an intended layout is just beginning.
It's a workflow that feels incredibly relevant no matter what your field is. I mean, whether you're writing complex functional code in Haskell or just trying to organize a messy spreadsheet for a team presentation, that cycle is universally familiar.
Oh, everyone has been there.
You rely on existing tools, you hit a bizarre invisible wall where the formatting breaks for no logical reason, and you end up using AI to brute force a solution.
Right. You delegate the tedious friction to the machine.
Yes.
Yeah.
Just so you can get back to the part of the project you actually care about, the creative decisions that make it look and feel the way you envision.
It highlights a real maturity in how we use these tools now. We're letting the machines handle the rote compliance, preserving our human energy for the subjective choices that actually matter to the end user.
Here's where it gets really interesting, though. We just saw how the AI automatically iterated to fix the underlying structural errors of that EPB document. It brute forced the blueprints so the house wouldn't collapse under the weight of an e-reader's strict rules.
Right.
But if AI is already mastering the invisible architecture of our files, how long will it be before it can also automatically anticipate our aesthetic preferences?
Oh, wow. That's a wild thought.
How long until it doesn't just build the structurally sound empty house, but flawlessly picks out the exact custom layout and typography we didn't even know we wanted? Something to chew on the next time you hit a bizarre roadblock in your own projects and have to rely on a little automagic to get across the finish line?